Alright, this is episode number 22 in the video series going from a complete noob to a veteran ASM coder. Alright, after this we will be on our final episode. So what do we got now? We got utilizing macros. Teaches you the in and outs in an ASM code's source. So once your codes get so complex, maybe with things such as function calls, or certain complex values, even basic values, if you're using them over and over again, it might be better for you to use macros in certain titles or names instead of writing the specific value or writing a list of instructions for calling a function over and over again. Or you're in a situation where you have instructions that could vary per region of MKW. So instead of having a source and putting, oh, this is the source for NTSCU, adjust the compiled code accordingly, you don't have to do that. I'll show you ways to where you can make sources where you can designate what region will be compiled when you compile the source, but it'll be all into one source. It wouldn't be a region-specific source. So this is highly needed or highly required when your codes get so big, so long, so complex. This is definitely needed. Okay, so now let's go with the most basic part. We'll be covering statements first, then macros, then if statements, and kind of combining them all together. Okay, so what we got here. So first, you can set basic label names, because remember we talked about you can use label names for branches. You can use label names for various values. I could do dot set amount 100. So anytime you use amount, it'll have that value. So you can do this for multiple things. If you're using a certain value over and over again, but maybe it's a unique value, something you're not used to working with, it's easier for you to remember the name. You can use these statements instead. So just like this. So check this out. You can use something like that. Maybe you have an amount you use a lot, or an offset you use when you store something, like in reference to this register. This will be at the very top of your source, and let's say you have a bunch of ASM right here, and maybe you get near the end. Oh, I know my label names. I don't need to actually rewrite the values. So let me just hashtag this here, and we will show that this is able to compile. Everything that's like presented in the thread is able to compile. So as you can see, it compiles. So that's how you set up basic statements or label names for various values. You can use this for like decimal, hex, and whatnot, whatever you need. Okay, setting a simple macro. So you probably have a code where maybe you're writing this a lot, or something like that. You're doing some reference to the exception register for maybe a various instructions, or storing various things over and over again, or maybe this is part of a function call. I don't know. But either way, you're using these two lists of instructions over and over again. So instead of writing those two lists of instructions, you could just make a macro like this. So what you do is you do dot macro. Some people will put tabs here like this, but it's not needed. But it looks more aesthetically pleasing to the eye. And then when you end a macro, dot M. Obviously M stands for macro. So this would be better to do. Okay, so this will work. You can just do that. And then you can just do something like, I don't know, let's go do something random. LISAAAO. And then you can just put set the address. If we copy and paste it, you'll see it compiles. So basically you would use .set for just singular values, and if you have multiple instructions or something, you would use a .macro. Okay, getting more complex with macros. Okay, so let's say we have this here. Alright, so let's check it out. So you set this macro. You can set label names within the macro itself. So check this out. We have this label name right here. So what you would do is, after you do dot macro, okay, or excuse me, this is just a title, so pardon me for that. You just set the title to the macro, the label name for the macro as usual, okay? And then let me just back this out really quick. Okay, so let's say you have these instructions, but the registers will vary, but the values here will stay the same, alright? You can still put this in a macro, okay? So for example, if you're doing this, you have to put this slash register. This tells the compiler that this value here is obviously for registers like R3, R5, R20, but they can vary. And you also designate this by putting the word register in the top right after the macro's name. Okay, and this is assuming like these values don't change. And then we just have a simple statement of the value, just a random value. So right here, excuse me, let's say you're adding R19 with your value, add the value, gets put back in the 19, and check out what this does. What this does right here, set the address. Now we're calling a macro, okay? It's going to use these instructions, right? Okay, but it's going to use R11. Notice how R11 is right after the macro name. So essentially, this, now just before we continue any further, I'm going to show you this actually compiles in Python. And all these work in a WeRDGUI as well. And as you can see, it compiles. So what this right here does, when we call the macro name, we put the register, and remember we put in the macro, we said the register, we were designating the compiler that the register can vary, but when you do that, you got to make sure you put the register's value, whichever one you're going to use. So what this literally does, set the register R11, is it takes this macro and fills in these slash register values with R11 like this. So there's a pretty complex macro that you can use to maybe you're setting some instructions to various values, some registers to various values, but you want to have the freedom to decide which register you want to choose. This would be a very good macro to use. This is something you would be using a lot. Okay, getting more complex at macros. Okay. Let's change the macro to allow the use of any address plus register, or any value plus register. So as before, the first macro we're using where we had the tilted slash, the backslash register, this would allow us to set any register value. But what if not only does the registers can change when you're doing these repeating instructions, the values may change too? How would you go about that? So this is how you would do it. Okay, let's get these comments out here. You can view the comments on the thread, but they take up quite a bit of space. Okay, so this is how you would do it. Macro, set the address. Okay, this is going to set, what this is going to do is going to set this address. But first of all, let's just go with the macro. We have the macro's name. So whenever this name gets put in the compiler, it knows to call the macro or use the macro. We're designating that our register value can change, put a comma, and the address can change. Now what an address means. This doesn't have to designate an address per se, but when you put the address, it just knows that this value, the 16-bit signed or logical value for the instruction, can change. We have the backslash registers accordingly. Obviously we have two for or immediate, because a destination register and a source register. And then we have this, the slash. Now at H is at the high, upper bits, at L is low. There's also a thing called algebraically, which we're not going to go into, but once you learn more about macros, algebraically just does a little different versus signed and logical, but you would rarely use it, so just stick to at high. So then we have a simple statement underneath, just using it with it just to show you can use both macros and statements, multiple macros, multiple statements in your compiler. So we have this typical add immediate instruction we were working with too. But now check this out. We have the macro's name, and you should know that when we put R11 next to it, it fills all this with R11. And now we have this. So what does this literally do? For one, it plugs in R11 here, here, and here. Okay, and it takes 8145 and puts it here. filling out this. It takes 8,000, the lower bits, and puts it here. Pretty simple enough, right? Okay, and then we just have this other random instruction just for viewing. So we could take that, put it in, throw it in the compiler, compile, and it compiles. Okay, so that is how you would set values. Like maybe you have instructions, a list of instructions you're using again and again and again. Not only do you want the freedom to set which register the macro is going to use, but also a word value that will split, like I just shown you, split into two 16-bit values. Okay, and if you're not using this or immediate, you can leave it like that and that'll work too. Or maybe you have a value that's just that or whatever. You can just put at address L and change that to load immediate. But anyway, you guys get the idea. That'll teach you how to choose which values and which registers you want to put in a macro instead of being limited like we shown with the earlier macros. Okay, so this one is going to be even more complex, using labels with address values and macros. Actually, we just covered that. Actually, did we? No, actually we didn't. Okay, so this is going to be even more complex. It's just just a step above. So we talked about setting macros to where you have the freedom to choose which register is going to be used for the macro and which address value or word value. So let's just get rid of these comments right here. Okay, now check this out. So we have our macro. We have our two values we're setting via statements. Now instead of let's say you're going to use this value, the word value that you want to select for here. Let's say you're going to use it quite a bit. You can set its own label name to that, its own statement, and check this out. Let's scroll down here, set the address. So we know the macro right here. It's going to use these instructions. We're using R11, so we want to use R11. But instead of plugging in the value, writing it, we just went ahead and made a label name for that as well, which is up here. So once this macro gets called, it's going to use 8042 for this right here, and it's going to use BABC for this right here. So just a step more complex, if you will. Getting more complex with the statements. Okay, we'll just go over these really quick. I never really had the chance to use these in a code, but if your code gets super complex with a bunch of label names, we'll just go over this really quick. Pretty simple. First, you set your label name for a value that you're going to work with, that you're going to be using for various multiplication, addition, and stuff. So let's say you're going to use this number a lot, but you may have a time where you need it multiplied by a certain amount or divided by a certain amount. So you create another label name that's going to use this label name, the base value, which is 6, base value, and you just plug in a little addition symbol, +2. So whenever you use this value, instead of having to do something like dot set another label 8 or whatever, instead of doing that 8 and doing that over and over and over again, if you want, you can do it this way. +2, this represents 6. You can just, and we called it +2. You can do multiplication. You just do the asterisk symbol. 8, this is for multiply. If you want to divide, you do a / symbol. Take the label name, / whatever value you want. You can do base value, -5. So you could do something like that if needed. I never really had a chance to use it, but just understand you have these options or when compiling. Okay, so using .set and if statements to compile different versions based on region. Okay, so this is how you would do it. And you guys probably seen this on a lot of codes I made. Okay. So this is what you have right here. We'll blow this up on the text editor really quick. So whenever you're writing source that has instructions that vary per region, we first do a simple statement, and we're going to call this region. Now you can call the label whatever you want, but obviously since this is for region porting purposes, it would make sense to call it region. Now you put a comma, obviously. You put 2 little dash marks, like quotation marks if you will, but singular ones. Alright? And then you go create these if statements. Now I know this is probably complex to remember, so what you can do is you can store these like in a text editor, and you always plug this into new codes, new sources that you write. So just basically you can copy paste this and use this format, and all you do is we have right here, see, so now what we do is we have this address. Maybe this is a address of a function call and it varies. So what you want to do is you're going to set a label name for it. Obviously use the same label name for each port because it can change. Set the USA value, set the PAL value, set Japan, set the Korea. So what's going to happen is if you use, I don't know, LIS R12, let's see, actually we're going to just go back really quick. Okay. So what you can do here is plug this in like this. So remember we talked about using label names for higher bits and lower bits of values. So what we're going to do is copy paste this. Something a little extra I probably should add to the forum, the thread, because in the thread it includes these two little instructions. So check this out. We have the 80, we have this value, this value, this value, this value. So depending on what value, see how it says region must equal E, P, J, or K, you plug in that value right there. So if we did E, check that out. You can see this compiled word right here is the LIS. You can see this or immediate R12 is this compiled word right here. Notice you see the 8042 and the 1500 matches right here. Now check this out. Go from E to P. Now watch the source. Boom. See how it changes? We'll do Japan now. Boom. Changes. And finally Korea, which changes the upper bits too. Boom. And as you can see. So I'll add in this probably these little two instructions right here underneath this, just so you guys can test that out. But just use this template if you have instructions or addresses or values that can vary per region. Okay, so finally, with all this being said, macros, using macros within these if/else if statements. So what we just covered was, what this does is it creates an if statement, and obviously we have these else if, then end if. Now one more thing I want to cover before we continue to that is if you put an invalid region like X, look what happens. .err encountered. Because you need something, you need a backup just in case someone doesn't fill this in or they put in an invalid letter or some invalid value that you don't have designated by the if statements. So this is why we have the .else and we do the .err. It'll tell the compiler, whoa, don't compile, don't even try to compile it, just set an error. So that's really important. So now we go to the final spot, doing macros within these if/else if statements. Go here, like that. So this is going to be a lot to handle. So first, we have a macro. We want to set a macro, but when we set this macro, the value that we're going to set the macro to is going to vary per region. And not only that, we want the ability to freely select the register that we will use for said macro. So I know that's a lot to take in, but with all that being said, this is how you would do it. Put your set region, use the template, but instead of using .set, you can put these macros in for the if, else if, and then we have the error backup for an invalid region. Now if you look at the macro itself, and just to make it a little more aesthetically pleasing to the eye, we'll go ahead and tab this. We have the macro's name, set the address, and obviously these two instructions are setting a memory address. We have to put register at the top right of the macro to designate that we're going to freely choose what register we're going to use at the time. And then we go and put the slash, and we put the slash registers for the LIS, the OR immediate, and the other OR immediate. So we have that set. And so this is just a random instruction right here that we just put some add instruction. And check this out. Here's our macro's title, its label name, set the address. See how these get highlighted too? I have my text editor set up like that. And obviously we have to select the register to use because we have that designated for each macro. And obviously remember, each macro, make sure they're exactly the same except for the values that have to change per port, per region. Okay, so we have the macro, and then we have some other random instruction that doesn't matter. So let's just go ahead and show you that this compiles. Okay. Oh, go like this. Okay, so fill in a value, you get E, and there it goes, it compiles. Alright, and if we leave the value blank, we get a .err, and we also get an unrecognized opcode because we didn't fill in a value, because the macro is not being defined as well. It throws a second error. Just plug in like J. You see, look at this right here, this compiled word right here, C1508. We change it to Korea, goes to 15.0C. Change it to PAL, P1504. So let's go over what exactly happens. First, you have your if statements, but you got to have your beginning statement first. Set the region label name, if, and here's the region label name for all 4 regions. We have the backup error that occurs if something goes wrong. And then we have our macros. Okay, we want to freely use a register in the macro. We change the values, okay, per region, like this. Okay, and then once this macro gets called, it goes views here. We're just using Korea for example, the Korean one. Set the address, so it knows to use the macro. It needs a register. We select R11. So then it plugs in R11 for this, for that, like this. And obviously this is assuming up here is K, because it'll read through all these if statements. It'll see it's the K value and uses that macro. So that is how you would do macros within the if/elf if statements, and you're working with different ports. Another one I would like to show you really quick is you can also, this is something really good to use too. So let me Control A this. So let's say you have something like this. We'll just, hopefully you guys can view it here, but be sure to blow this up. Essentially, just look at this call no link macro right here. So we set a macro, and we want the register, the same register R12 to be used every time, but we want the ability to change the address or the value that's going to be used. And this value, okay, is going to change per region. So let's say you have this macro and you want to do that. Okay, you need the dot set region. Now I'm going to copy paste this. Okay, so let's delete a lot of this stuff right here. Just delete most of this so you guys get an idea. We don't need all these here. And we will go ahead and tab this all. Tabbing makes it a lot easier to see. Okay, so check this out. So we make our macro, alright, but it doesn't, we just want R12 used every time, but we have an address value that has to change. Alright, so then we're gonna set a label name that varies per port. Its value varies. Alright, but obviously the label name has to be the same. So what happens is, what you want to do is, if you're going to call this macro, let's just say we have a random instruction here, we have another instruction here, like this, and now you need to call your macro or whatever. How would you do this? Well, first you put the macro's name, like we talked about before, call no link, space, we have to fill in the address. Now remember, this is an address value and it varies per region, but we have a label name for it. So then we do net calc. And what happens is, Control A, Control C, when we put in the region value for this, it'll take the representative or the value that's supposed to be for the region. It'll select the right one depending on which letter you use for the region, plug it in for net calc. So when the macro gets called right here, it plugs in the address for the upper bits here and the lower bits here. So let's see that all combined into one thing. Control A, Control V. As you see, we got net calc. First, if you forget to put the region, compiling error expected. I'll put E, check it out. Boom. Let's say we use K. Watch the values change. boom, and they change. So that right there, guys, is a really complex tutorial in setting macros. One more thread you should view is the screenshot code by Star. In his source, if you scroll down, it's just a ton of statements, a ton of macros. Really, really good to use. Okay, and that is it. After this episode, or excuse me, the next episode, will be in the final one in our ASM journey, all about bit rotation. And that is it, guys. That is how you utilize macros in complex ASM sources. Thanks for watching.